problem? Well, I want you to follow me down to the bottom, underneath the insane asylum. Keep your wits about you while you got them, cause your wits are first to go while you're problem solving. And my problem, we glorify those even more when they...
Hurricane Helene, a storm that seemingly formed out of nowhere and caused mass destruction and devastation across the Floridian coast and the southeast. This storm ranks amongst some of the strongest to ever reach the Gulf Coast as a Category 4 hurricane with maximum sustained winds of 140 miles per hour. Its lowest pressure recording at the time of its landfall near Perry, Florida, was 938 millibars. And as of right now, I'm recording this on the last day of September 30th, 2024. Current fatalities are over 100 right now, and there are over 600 people unfortunately missing, and these numbers are both only expected to increase. Guys, these are deadly storms that we're dealing with, and it's unfortunate to be dealing with what Mother Nature throws at you. Except this is not Mother Nature. It's pseudo-Mother Nature, and it's folks and people that are manipulating these storms. And upon further investigation, I will break down in detail how they're doing this. Thank you guys for watching this video. I'm meteorologist Will Danby. I got my degree at Ohio State University, proud atmospheric scientist and Buckeye. And we're going to go into, in depth, how they manipulate these storms and they cause mass destruction and damage people's livelihoods. They go after the crop productions and they go after farmers and they essentially just destroy your livelihoods. This is an attack on the American people, and this has actually been going on for near decades. Ladies and gentlemen, they have been getting away with manipulating these storms, all for sensationalism, and the public, for the most part, doesn't bat an eye at this. You're all under a trance, and it's important to bring this to fruition, because in joint efforts with the National Weather Service, NOAA, NASA, all these joint organizations that are run by our Department of Defense and the government are all the ones that are doing this, and they're all the ones that are responsible for this, and they allow this to happen. Let's go ahead and go through some very sound analysis with this, guys. I'm not sure how long this video is going to take. I've compiled nearly 200 slides of data here to look at. Now, a lot of this is going to be frame by frame analysis to dissect this, but let's take a look first at the rainfall that occurred out of this system. Catastrophic flooding and rain and mudslides, especially right along the Cumberlands here, the Blue Mountains, and along the Appalachians, especially right along the Carolina and Tennessee coast. Anywhere where you guys see blue, this is that 5-inch threshold of rainfall here. So you can see that really the lighter blue shades, we're talking in excess of 10 inches of rain falling in some spots here. This is catastrophic flooding, catastrophic mudslides, and unfortunately, while the immediate impacts of the strongest of the winds were felt right along the armpit of Florida here, the storm surge and the flooding produced by this is actually far more dangerous in terms of the water damage, the infrastructure, the overload on our water drainage systems, our dams. This is backbreaking to our infrastructure, and that's what these storms do. They destroy this. They destroy your guys' livelihoods, all while you think this is just something that is an act of God and Mother Nature, but this is not. It's what I'd call pseudo Mother Nature, or weather manipulation or modification. So let's get into, at first, the conventions here, what we're used to seeing in the public. And this is just a surface analysis chart. And we're looking at September 25th, 18Z, which is around noon or 1 o'clock in the afternoon. Here's Helene all the way down near Cuba. It's just off the page. And this is a cold front that extends from Columbus, Ohio, really almost all the way down to Houston. This front here will become a stationary front. And what this will do is it will prevent Helene from moving anywhere further towards the northwest of Florida. So this is a bottling, so to speak, here of an air mass that's going to help allow and steer this storm to come up through the armpit of Florida. Let me go ahead and get out my drawing tool here. So it's going to come right around this way of this nature. So as we roll through this frame by frame, another thing you need to watch for is this low pressure system that's sitting up here in Canada. This will also help to direct and steer this hurricane and keep it funneled across the lower Ohio Valley and the southeast coast here. So as this continues to pull up into the Gulf Coast, undergoes rapid intensification, reaches and strikes landfall there around the armpit of Florida near Perry. And again, you can see the stationary front. This is like a blocker here. This stays to the east of this stationary front. We have a strong low up here that's sitting across New England that's going to help put a cap on the northern part here of the United States. And then there is a cold front that's coming from the northwest. This is what's going to generate what's called an upper level low. It's in the upper level features of the atmosphere. And this is going to help create, in essence here, like a yin and a yang. As we have a deepening upper level low, that's going to help direct and guide this hurricane and pull it off towards the north and eventually the northwest here. So you can see as we get into the noon time frame on Friday, September 27th, the storm dissipates over the Appalachians here near Tennessee, and now we're left with just a tropical depression. Now, here's a same look at what we're analyzing that I've just showed you, but this is the upper level features. This is now looking at the 500 millibar height. We're looking at a pressure field, and anywhere where we see a solid black line, this is called an isobar. It's an equal line of pressure. So this means if I'm looking, let's find an easy arbitrary point here. If we're over in southeast Ohio right here, and we go all the way down to the the Oklahoma and Texas border here, this would mean these areas have the same pressure. They're along the same field, at the same equal line of pressure of an isobar. Another thing to take into account is this is up at the 500 millibar level. This is generally about where airplanes are flying when you go up in a passenger jet. So we're looking at the pressure field all the way up where these airplanes are flying. So what you'll notice with time is we see this big dip here. This is going to develop an upper level low. So again, we're in the upper levels of the atmosphere, about 30,000 plus feet high. And as this continues to develop, notice this becomes a closed circle. This is what's called a closed low, a closed upper level low feature. And what this does is this spins counterclockwise. So as this is spinning counterclockwise, it is going to help direct and lift Helene up into the coast here along the armpit of Florida. This is Helene down here. It has closed lows all the way up at the 500 millibar height level, but you can see how these two lows are going to interact with each other. Again, this is Helene, and this is an upper level low. As we go to the next slide, look at how these interact with each other. This helps lift this up because this is also going to be spinning counterclockwise here. So this is what's going to help steer this. And again, I want us to note this low that's also up here. The low that's up here is also spinning counterclockwise, and it's going to help put a cap up here to prevent anything else from exceeding north of this line that I drew here. So these three lows are huge in the overall progression of how this plays out. This is how they steer this hurricane and they park it in a controlled environment, in a controlled atmosphere. You can see as this lifts up, here's Helene. It lifts up into Georgia and into South Carolina, and it gets absorbed into this low because this low is already spinning counterclockwise. So as it lifts this up, it essentially absorbs the remnants of Helene here, and we get this massive upper level low that will spin across the lower Ohio Valley. And again, note this low that's sitting up here, this upper level low, sitting near Maine. Again, this is going to keep everything bottled here. It's like a bottleneck. It caps everything. Nothing will lift further north than this area here. And so you have this closed low environment that's allowed to exist in its own essence, essentially. When we combine those three ideas together, this is how these look in conjunction to each other, okay? We can see Helene at the beginning of the loop lifting into the Gulf Coast and makes landfall, again, right near Florida, lifts up into South Carolina, Georgia, North Carolina, and then dissipates. Here is that low feature, again, that's sitting up here, that caps this. Notice how throughout all of this loop, there is a reluctance for any water vapor here to project any further north than this, as well as anything really struggling to get past this area as well. This is a controlled and fixed environment that allows this to exist. Another thing I want us to keep in mind is notice this low spinning up here. How many times can you guys count boxes or 90-degree angles like this? We essentially have a shape that looks like a box here, and it's rotating counterclockwise. You can see that occur many times here where we have boxes. Anytime you have something forming at a right angle or a 90-degree angle, this can't happen in nature. It's not possible to have 90-degree angle clouds. So this is, again, as I said, it's capping the environment here, and it's allowing this to sustain itself in its own closed atmosphere. Here's a look at the sandwich layering. All this does is it looks at cloud top heights. Anywhere where we see deeper oranges, this is higher cloud tops. It's easier at picking out convection, and convection is just simply the building of thunderstorms. So this can be helpful at looking at the core of the eye of the hurricane to see if it's strengthening. We can see there's a nice pulse here on this northwest side that indicates very efficient flow with this before it hits land and makes landfall. We notice this very almost rusted color here. That's a signature of a very healthy storm, and unfortunately very strong winds would have impacted anywhere along this area of Florida. Another important piece to watch out for is let's take a look here across central Tennessee and Alabama. You'll notice what looks like spokes like this. This is a pulsation frequency here that runs south to north, and it again caps anything from getting further to the west of this line. Nothing will get over to the further west of this. It bottles this hurricane and keeps it where they want to target it and direct it. I want you guys to keep this in mind. I'll revisit this as I'm just glossing over it. And I promise you right now, this will be the most difficult attribute to pick out, and then everything else is going to get easier here with the characteristics I'm trying to bring out and have you guys see. So this is the early stages of the development of Helene. This is before it's even a hurricane. This is its tropical storm development here. You can see the core of the low on this system is spinning right here. So this is where it's starting to organize, and it moves slightly this way throughout the loop. But what I want us to watch out for is the lack of clouds and the lack of moisture that simply fails to sustain further east of this line, okay? Everything stays off to the west of this line. This is signature of keeping a bottled atmosphere or a controlled atmosphere. We see on the upper level height, again, we see a cold front coming through this way. This is also helping to pinch everything off with this stationary front to bottle everything into the Gulf. There is also a tropical system in the Pacific here that is also working to bottle this in this nature like so. And so what you have is this hurricane, or soon-to-be hurricane, is in a controlled environment in the Gulf. And I'm sure a lot of people along the south, the south, the Gulf Coast here, know how much of a bathwater the Gulf is. It's very warm waters. We're talking temperatures in the mid-80s. Some of them even reach up into the low 90s. It's that warm, and that's just juice and energy for these hurricanes to form. And it's not a surprise that it takes this path. It goes right over very warm waters, and it's able to rapidly intensify in an unnatural way. Here's the same loop, and I've sped this up. It's very fast. I've found if you do this very quickly, it picks out the best attributes. You will see pulsation frequencies or essentially almost like phasers that shoot really fast in this direction. These move extremely fast, and what these do is they work to excite the system and lift it north. So if they go really fast like this, they're like shot off here like pulses. Helps lift this up. Again, you can see here's this cold front that progresses, and it helps to bottle this up and direct this right where they want it to go. And again, here's the other boundary from this other tropical system that helps to inflow this from behind. So this is how these are all working in tandem to create this manipulated atmosphere. Here's another look at this. I tried to draw out this yellow arrow. If we just observe along this yellow arrow and let this run a few times, you can see that there are in fact pulsations that are lifting off to the northwest here. And another peculiar thing is we see cloud clearing right through this instance here. You'll see cloud clearing once we hit daytime in this area. It's after we come through the nighttime, so this is now daytime, and we see clearing happen right there with pulsation. And so this is again indicative of guidance here. This is helping to direct this. We're emitting frequencies into the upper levels of the atmosphere that are helping to push this to the north. And eventually, as this cold front dives south and east here, it's going to push this and give it more of its northeast turn here. Notice it's moving out in this direction, and then it takes its turn this way via the help of the pulsation and this progressing cold front that soon becomes a stationary front. That's the hardest thing for you guys to pick out. I promise it'll get a lot easier. Here it is in very high resolution, slowed down. The easiest to pick out on this is at the beginning of this loop. So we can see a pulsation that's shot off through here. Then we see there will be clearing across Cuba. Once we get into the daytime at the beginning of this loop, there's clearing that occurs here. And I'll get us in even closer on this to take a look at this. Another peculiar thing to watch for is notice this convection that occurs right here. This is something right in this area. Watch this cloud here. This lifts up here like it's being magnetized. Here's the edge of it, and you can just see it shooting right up here. Very strange occurrences, and again, nothing wants to develop to the furthest east of this line. Anything struggles to develop here because this is where your boundary is that's capping this hurricane. And again, here's the area that we're watching. Is this in this red box where we can see this pulsation lifting this storm, helping to lift it up. It's especially pronounced at the end of this loop. Once this pauses, you can see really, I can draw right along this here. And again, that's what's helping lift this storm up. Here it is very close. This is Cuba, and I'm going to go ahead and run through the loop on this here. And we can see this is where this clearing occurs. And you can see that this is the ionized channel here that's allowing these pulsations to occur. Let me go ahead and play this again. There's the clearing. We see clearing, and we see these uplift. We see pulses of uplift here. Again, this is the hardest thing to pick out. You have to have a very good eye to see this stuff because it is occurring extremely fast. So that's important to note with this. And then once we run through this very fast on mid-level water vapor imagery, this is simply just looking at how much water vapor is available in the mid-levels of the atmosphere. Anywhere where we have our greens, that's going to be more saturated. Anywhere where we have our yellows and our reds, that's going to be drier. And again, you can see cases where we get pulses that help lift this up. Here's that cold front of that dry air. I keep drawing this over and over again, as well as the outskirts of this other tropical system here. You pinch this off and you have your own closed environment. And I want us to note as well as watch this dry air just essentially shoot this thing out of here, okay? This comes in after it makes its landfall near Florida. You see this back edge just shoot this thing out of here. This dry air comes really fast, like a bat from hell, and just lifts this thing out of here. It catapults it out. Very, very unnatural for this to occur. And this is what I mean with this. You can see here's this upper level low. You can see there's a pulse that's clearly shot down here that's helping to direct this. We also see, as I said, it's like a yin and a yang type of deal here. Here's your one low spinning this way. Here's your other low spinning this way. Here's your central axis. Your central axis sits right here. Nothing can form to the west of this. This is very strong dry air. And in order for this storm to generate its uplift, you have to have some give off to the northwest of it, and that's what this upper level low does here. It helps to propel this storm and lift it off towards the north. Another thing I want us to note is look at how, again, this is very linear in nature. We can almost draw out certain instances here of kinks in the clouds or 90-degree angles in the clouds here. This is looking at that mid-level water vapor imagery, and now this is looking at the upper level water vapor imagery. This is the same loop. We're just looking at, again, the upper levels, and I want you to note the collision of this dry air where it meets the saturated air. You can see there is some kind of excitation here that looks like pulsation that's helping to tear this and lift this up. Another thing that's important to take into account is the barriers of these clouds here that look like stitches. If we watch across these areas here, we'll see what looks like clouds that look like this. It's like football stitches. And they move with time. They have a back edge on them. And again, they're similar like pulses. They lift to the north here. We see one that got shot off there. Here's another one that shoots. These are essentially what they are as advertised. They look like stitches, and they behave like that. They hold certain components of our water vapor in place. It's very pronounced at the end of this loop here. You can see right in this area here at the end of the loop what looks like these stitches in here. These are shooting frequencies off to help make this barrier. It's going to draw down this dry air, descend this dry air, further exasperate it to help propel this hurricane and lift it up to the north. When we put this all in motion, we can again see this upper level low. There's very strange pulses here. It looks like deliberate protrusions that shoot out this way. We see kinking of clouds like this when this occurs, and then we see this storm essentially get catapulted. And I want us to keep in mind, look at the end of this loop. Let me go ahead and erase this. Look at how unnatural this is, guys. At the very end of this loop, watch this dry air. It makes a triangle of, again, angles. We can shape these out, okay? We have stuff that looks like this. This is not naturally occurring by any stretch of the imagination. We can't have pinched 90-degree angles of dry air. This just doesn't happen or occur in nature. It's not possible. This violates atmospheric thermodynamics and dynamics as a whole. Here's a look at it again. You can see the development of, again, what looks like kinked clouds, or clouds that form 90-degree angles. And the next thing we're going to look at here is the NEXRAD network. Now, with NEXRAD, all of these exist on a grid. Anywhere where we see these dots here, these are all radar sites, and these all work in conjunction with each other. They all communicate with each other to work in a network to also help excite this and propel this storm. We see very, very strange protrusions here where this rainfall is traveling much quicker than everything else is. Again, this is what I'm talking about, where this is helping to lift this hurricane up and into the southeast coast. I'll have a little bit more on NEXRAD in just a second here, but we start to see some very strange occurrences again when we watch this. Notice how everything, it's like when you stomp on the ground, it's going to cause a rippling effect. Imagine we have a giant that's sitting out here in the Atlantic Ocean, and this giant just stomps its foot down as hard as it can. It sends a rippling effect from east to west, and watch all these light up. Do you see how they all light up from east to west? It's most pronounced here. While there isn't any precipitation occurring here, you see as these turn on, this is what's helping. Again, watch how this is all being magnetized this way. This is all being brought down this way. It thumps, it turns on, and we can see everything is being sucked down to the south and east to help lift this hurricane up. Here's a look again at simple water vapor imagery. This is most telling to see how this upper level feature here across Illinois and Missouri is being generated. We can something shoots an ejection out right here. Here it is. This is forced manipulation of water vapor. And as this occurs, again, this upper level low, it'll swing down like this. And when you swing down, it helps to scoop this up. And what they do is they descend all this dry air into it to help force this hurricane and lift this hurricane up. Another thing to watch for is again, the descending dry air across the Rockies here. That's something that's also very peculiar and strange to me. And again, we see the reluctance of clouds to go any more further north than that line I just drew up here. That's a signature of a capped environment or a controlled environment. Again, I'll bring up the point here. We see kinking here. Here's this boxing of this low spinning. It forms walls here. It's a controlled environment. We do something like this, and this is your bounds, guys. This is how you control really this entire apparatus here. You descend all this dry air in here, and it's like a catapult. We're talking 18th century and older type of technology, like you're firing a sling, like a catapult, like boom. And this catapults and it shreds this hurricane apart and lifts it up here. Here's a look again at the mid-level water vapor imagery. Watch what happens here. We see cases of, again, kinking of our dry air. We see it through here. We see it through here. It's like around a fulcrum. It's spinning around a fixed point, and it helps propel and lift this thing out this way. This dry air shreds this thing apart. Let me go ahead. I'm going to erase this and go through this again. I want us to watch right through here in relevance to the hurricane's movement, okay? As this dry air swoops around like this, it's lifting this thing up and shredding it. And then once this gets to about Tennessee, we see a case where this is kinked like that. So this lifts up here, and then here we go. We see that pattern, and again, we see a perfectly flat line, a linear path of deliberate forcing of dry air here. It's like the yin-yang symbol. That's kind of the best analogy I can deduct from this. But you see how this is all working in tandem, in a balance, guys. At the beginning of the loop, the dry air is like this, and it rotates counterclockwise. So it's here, it's here, it's here, now it's here. And it's being drawn in artificially. We see this low up here. This is what's helping to place and block everything from going further off towards the north. And then this is what follows, guys. It creates, again, I can't stress it enough, this closed off atmosphere to create the environment for this hurricane. Now, here's the upper level water vapor. Again, it's the same loop that draws this out for us. We can see, again, watch in here, very, very strange pulsation or frequencies that look like they're rippling out of here. And then this continues to lift off towards the north. And yet again, notice we have this pinched off triangle. And then we get the kinking here of this dry air. And again, this is all in a controlled atmosphere. And what you start to realize is the way these things work is it is like simple mathematics in the sense that it's shapes and patterns and geometry in order for these to be executed. And that's all this is they treat this atmosphere like it's a geometric shape and geometry, and you're able to execute this kind of stuff. Now, here's a look at this in motion and slow. And we can see, again, here's the kinking of this. We see it maintains its obtuse angle in the dry air. Here's more linear nature of how this behaves. And we can see almost artificial type of lift here that's just helping to shred this hurricane apart, okay? It shreds this thing apart and it fans out this way. Okay, the hurricane is gone. It's dissipating at this point, and it fans out and it shreds out to the north and to the east. Something peculiar to watch as well is watch what happens in these clouds here. Notice these ripples, guys. This is an excitation. This is pulsation. This is being excited via electromagnetization and ionization. Another thing to point out is notice how everything is magnetized right here. Watch this as this lifts up. It's right over here. You see how everything is being fixated on this point. Everything is lifting to this area here. Okay? Very, very strange. I want us to watch this area with my pen right here. It starts right here, and we can see this is where the easiest and most evident forcing is occurring. Okay, we see stuff moving this way, and we see stuff moving this way. And it intersects at this point. You see this? See what's going on here? Meanwhile, look at these clouds. These have ripples. They look like almost like ice cream, rippled ice cream. This is telling you guys that this is being excited via EMF here. This is excitation with magnetization. This is not behaving naturally, guys. We don't see this with clouds. A type of funneling here, or a conical pattern here with ripples in these clouds. It's very disturbing to see this kind of stuff occurring and happening here. And then the other thing that's very strange to me is they call this the final advisory of post-tropical cyclone Helene. Okay, this is not Helene anymore. This isn't the same upper level low. This is just an upper level low, guys. This is not the cyclone anymore. It was torn up via the dry air, and we watched this thing disperse over the mid-Atlantic, okay? Watch this. This is Helene. Helene goes right here, and it gets torn up, and it goes out to sea, okay? Helene is out here. The rest of its remnant field gets wrapped into this upper level low. So to call this Helene, that is absolutely false. This is an upper level low feature that was in place before Helene lifted into the area. It's just the dry air essentially tore it apart, and it turned it out to sea. And what we have left over is the same upper level low. This is not post-tropical cyclone Helene. It's simply false, guys. Let's put this in motion again. Here we go. Here's our catapult lifting this hurricane and just shoots it out. Here's our angled dry air working its way through the area. And again, here's our triangle and our fixed environment that helps lift this up. Here again, we can see those pulses that help lift this on both ends here. And then the dry air sinks its way through here and just tears this storm system apart. Can't stress this enough. Again, look at how strange this is, this rotating box-like cloud or low pressure system up here. And then here's a look at, again, NEXRAD, the whole radar network. Very strange occurrences off the coast here that help lift this storm. These all work in tandem together. It's called a network. And with any time on these, they can communicate with any other radar site here. So for example, let's look off into North Dakota. We have a radar site here. We have a radar site here, and we have a radar site here. These can connect to each other like this. And this can also connect to, let's say there's another radar network right here in South Dakota. This can connect like this. This can connect like this. We have another radar network here. This can connect like this, and so forth. And you see, as you go on and on with this, you make an entire gridded network that's able to manipulate this and help control this. It's like a switch. You turn it on, you turn on your pulsation, your frequencies, your excitation frequencies at a specific time frame in order to execute this. Now, the problem is, if you don't execute this at a proper time, it's painfully obvious that you can see geometric shapes. And that's what I'm going to get into to close this video here in just a second. Here is a still frame of looking at visible light of Helene. This is just looking at all of the clouds here. And again, this is the center of circulation of Helene. And I want us to note, again, look at how strange this stuff is here. We see these arms and this indentation in our cloud field. This is very odd, guys. This is indicative, again, of almost like a pinwheeling propeller blade type of an apparatus here that's going to help direct these and move these out towards the west. Okay, here's the center of your hurricane, and again, we can see there's signatures of indentations in these clouds and dry air. Here's a lifting pulse that again helps catapult and lift this out of here. This is your dry air. We can see there's obviously lines that occur in these clouds. Why do we have perfectly linear lines in our clouds? That's impossible. It can't happen, ladies and gentlemen. And here's how we loop it. And again, watch how everything is fixed on this point. Here's our pivot. Everything's lifting up this way. Everything is magnetized right here in the clearing of these clouds. You can see we have it running this way and running this way. It's all fixed on this point. Magnetization. These clouds are all excited like it's a magnet, guys, and that's how this is able to be executed. That's how these systems work. Here's another look at this. Again, look at the rippling of these clouds here as this whole apparatus pivots this way. Here's our boundary. Again, everything seems to be attracted to this fixed point here, and we can deduct this. We have uplift here, and it goes up this way, and it goes up this way, and then eventually now this starts turning on and moving this way to help direct this. Here's another look at this. Again, it's just in higher resolution. This is on CSPP or CSPP Geosphere. Again, this is looking at the nature of this. We can see that everything is attracted to this one particular point. Very strange occurrences again, guys. This is indicative of just behaviors that do not occur naturally. Again, you can see linear clouds here that do not occur in nature. Here's a look at the infrared cloud tops. This is more of upper level. And again, you can see, look at how strange this is. Everything is being funneled like this towards the end of the loop. You can see a pulse turn on here. It's like whoosh, and helps lift this in here. Here's another linear cloud that lifts up. All of this, I can't stress this enough, is indicative of non-natural occurrences. And again, look at in here across the Appalachian Mountains. See this stuff in here? See these spokes? This is microwaving occurring here. This is drying out the atmosphere. This is forcing dry air in here to help get this to generate its turning. Another thing to watch for is look at how strange this is at the end of the loop in Iowa. Again, we have football stitching here. This is a blockade, guys. This helps cap your atmosphere, and it helps block in and bottle your water vapor in a fixed point. This is where the fun begins. This is how the NextRad network is all working in tandem with each other. You can pick out linear characteristics pivoting around a fulcrum or a fixed point. In this case, this particular radar network here, this is the Louisville radar, and another important piece is going to be a radar here in Tennessee. There's going to be one that pops here, and this is like your bottleneck here. No precipitation forms south and east of this line. That's extremely strange throughout this entire loop, guys. So I'm going to just at first go ahead and run through this and not say anything. I just want you guys to kind of absorb this and watch how you can pick out geometric shapes, patterns, lines, circles, and triangles. And this can, again, be executed at instantaneous moments in time, like a program. This is the NextRad network working together in tandem. And again, this is a radar site, this is a radar site, this is a radar site, this is a radar site. All these, this is the whole network. And again, these all can communicate with each other. This can communicate this way. This can communicate with the Green Bay radar. This is the Madison radar. This is K-Lot right here. This is the Chicago area radar. And in a case out here, like this, go out into Nebraska, these radars have range of about this far. I drew this very poorly, but I want us to imagine, let's say this is where the center of our radar is. Okay, the beam can go all the way out here, and this beam rotates like this. Okay, it detects what's in the sky. And so when we have all these working together, you can create almost infinite possibilities. As I said, these can communicate with each other. This is the Des Moines to the Davenport radar. You can connect the Davenport radar to the Chicago K-Lot radar. You can have the Madison talking to Davenport. And see how it creates a triangle here, guys? And then at the same time, these radars spin, right? So you can rotate these. And so now you can get like what looks like a rotating triangle here. So let's go ahead and run through this, and you will see that we can pick out shapes. And this it just doesn't happen this way in nature, guys. It's impossible. It's impossible to have these occur. So I'm going to be quiet here. I'm going to just roll through this a few times and let me know what you guys see with this. Okay, so that's what it looks like here. I'm going to go ahead and back this up really slow and reverse it. And you guys can see here how this is all working in tandem. We can see a triangle here with these radar beams working together to create this and to propel this rainfall. And we can get these geometric shapes here. I didn't draw every single line, guys, because the point of this is I want you to discover it yourselves and play around with it. I give you some hints. I drop hints here of subtle cases where we can see geometry occurring. Here is a circle. You can see the outline of a circle. It's most pronounced across the northern third of Indiana here. You can see the edging of it as this thing lifts. And then I want us to note that the cluster of storms right here moves relative to this cluster this entire time. And so this creates, again, your network of cases where precipitation is almost communicating with each other. Very, very odd stuff going on here. So you cannot come at me and tell someone that this is natural, okay? If this were naturally occurring, we could not be able to do any of this, guys. We can't pick out linear rotating beams or circles or geometric triangles, coinciding triangles inside spheres. It's extremely and painfully obvious here. And note how these all turn on. Look at how active these radars are, okay? At the beginning of this loop, they're not as pronounced and they're not as active. And you can see that here. See, look how they shut off. They shut off here across Iowa, Wisconsin, Minnesota. And then as you roll this, these things, they turn on. So while these radars aren't detecting any precipitation, they're still serving a role in capping this, okay? They're still active in the sense that they're preventing any of this rain from moving further to the west. So all of this stuff, again, becomes a controlled environment, guys. This is all working in tandem in respect to time, space, north, south, east, west, and your Z plane here, or you go up in a vertical column of the atmosphere. This is all working instantaneously together. And the NextRad network, in order for this to be executed, I believe this is being done on a satellite, because in order for someone to humanly execute this, it makes my mind just spin. So it's almost like you transmit a program into a satellite. These satellites communicate with the NextRad network, and that's how they're able to execute this stuff and create entire systems like a simulation, or almost like a video game simulation here. So the way this works, again, for another visual, if you guys want to play along with me, let's imagine these are our 3 NextRad networks, okay? Actually, I'm going to save this for a different time because I don't want to confuse people, but I can save this for another video on how the NextRad networks work here. But let's go ahead and just kind of keep rolling forward with this. And here's again a closer look at the simple water vapor imagery. It's combining all the levels of the water vapor. And here you can see very strange instances of linear clouds yet again helping to direct this. We see how this pushes this through here, and then we can see there's a just rectangular lack of clouds that occur across or close to the Wilmington radar and across central Indiana. Let me go ahead and get my pen out here. It's at the end of the loop, and that's the point here. Watch what happens, guys. You can see, here's your line. Here's a rectangular area of dry air. Anywhere where we see black, this is dry air. Anywhere where we see deeper whites, these are higher cloud tops, or essentially more water vapor. So anywhere where we see more whites, that's more water vapor. Anywhere where we see blacks, that's dry air or lacking of water vapor. And we can see that there's deliberate pushing that's going on. So as this feature rotates, we see these pushing in and creating this, and then we start to see one clear out this way and push this in this direction, and that's how you get this counterclockwise flow. Now here's a look at the sandwich imagery again. I want to kind of get to the end of this here and take a look again at how this is being manipulated. Here we can see a dang near linear line that has obtuse angling on it, guys. See how this is all being fixed? And here's your microwaving. You can see a beam of microwaving occurring here on this western flank of the system that's exciting this and shooting pulses up. And again, this microwaving helps to block this and prevent this storm from going in this direction. As this lifts up, we see that this upper level low feature swings down, and then we get help with pulsation riding to the north this way. It's very pronounced here. You can see some remnants of the pulsation occurring this way, and that's how we can manipulate and direct this thing wherever we want it to go. Another thing I want to close with, guys, I have never seen this in my history of forecasting hurricanes. On September 24th, this is one of the first initial advisories for Helene. This was before this was even a tropical storm. I am just flabbergasted at the fact that we can say with such certainty about 3 days prior to landfall, that we're going to have a major hurricane hit the armpit of Florida when this storm hasn't even fully developed yet. Meteorologically, from a dynamics perspective, how can you say with such certainty when an event hasn't even occurred yet? We don't have enough ingestion data or polling data to know of what's even sampled down there, okay? This is a potential tropical cyclone at the moment of this update. A PTC, guys, means that from satellite imagery, it looks like there's a closed low of circulation, but we haven't had hurricane hunters go out there and actually verify that this meets those characteristics. So this advisory was issued prior to having any hurricane hunters going in and sampling this storm. So this is what's preconditioning people now as the new norm, okay? We always talk about trying to increase forecasting accuracy, narrowing down forecast cones to give people the best and most accurate information in the most timely manner possible. That's adequate for public safety. But the problem is, in the area where you start to run into danger with this, guys, is when you already can fix a storm and you already know where you're going to put a hurricane, the rest is set in stone, okay? They already know this, and that's my point. You can have a potential tropical cyclone without any sampling and already tell people that you're going to have a major hurricane hit exactly where they forecasted it to go. This is different in the sense that we already have a tropical storm that's formed and is established. There's a difference with this, guys. This is a case where this storm wasn't even developed yet. We didn't have any sampling on this yet, and we're already forecasting a major hurricane. Do you see the problem with that? That's very dangerous category to go into with that high of certainty. I've never seen anything like this, guys, in my forecasting history. It's very alarming to me, okay? And it's very easy to see this when you unveil that fabricated lens that this is natural weather. It's not natural. It's so easy because they're telling you this is where they're going to put this hurricane, okay? Here's a look again at just the devastation of how strong this was. And again, look at this area where we do not have any precipitation occurring. Look at how everything is being magnetized this way. This is being magnetized, pulled this way. This is helping to draw this up. And again, here's our other bound. We see more funneling here. Nothing, guys. Nothing is off to the east of this. I mean, it's so bad. Okay, and you can just decimate areas here, and we go this way, and we go this way, and here it is. You guys can just deluge this with rain, and as Helene lifts up into Florida, then you bring on this onshore flow, and that's how you're able to just obliterate these areas right here with heavy rain. This is absolutely disturbing. Here's a look at this again from a different view. This is where we have our capped dry air here that's helping to funnel this. We don't have any moisture that gets off to the west of this line. We have the protrusion of this upper level low that swings down this way, that can help catapult and lift Helene up. And then we have this controlled atmosphere that helps lift it up. And then we have another one that doesn't allow anything to go further to the north than this yellow line here. So we create, in essence, guys, a controlled atmosphere. We have a bottled atmosphere where we can have a fixed amount of water vapor. We can time this, we can make storms, and we can direct them and put them wherever we want to go. This is very dangerous stuff, all while making you believe that this is natural weather. An absolute monster of a storm. Here is, again, very, very obvious microwaving going on the northwest and western flank of this storm. These are pulsations that help cap this and excite this and prevent this from moving off to the west. So they get this going where they want it to go. And again, look at the deep convection on this, guys. Anywhere, look at how impressive this is. The blacks on this. This is signature of a very healthy storm, dangerous, deadly, devastating storm that's just going to tear through and wreck everything in its wake. And the last thing I'll say is this is independent of looking at Helene, but watch what goes on out here. Do you guys see in these areas? You'll see rippling. You'll see rippling in these clouds. It looks like this. And the ripples travel out this way. It's like, let's say this whole area, this whole map is a pond, and we drop a rock. We're going to drop a rock in a pond. Like, let's say we drop this rock right here, okay? When you drop a rock in water, everything's going to ripple out from it in a circular pattern, right? So I want us to watch this again. And this is, again, characteristics of non-natural occurrences. You drop a pebble in water, there's where you drop your pebble, and then you get ripples that concentrically travel outside of it, right? Like this, they ripple out. That's just water energy, right? It's going to ripple its way out of here. So let's go ahead and play this for us. Look right out here, and you can see it occurring. Again, I'm going to box it right here. This is where we need to watch. And we can see like someone threw a pebble in a pond, and we can see these clouds, especially in here, rippling. I mean, this is absolutely something else, guys. Also note that it's radial. It's got curvature to it. It's rounded. This behaves no less different than if you're dropping a pebble inside water, and you get the rippling of the waves coming out of it. Here's another look at this, guys. I'll play this frame by frame. Again, the red rectangle here, this is your pulsation of your microwaving, your stitches that help place hold this, prevent this from moving further to the west. Almost note here that at this particular point, the hurricane almost takes a little wobble to the west here. See how it almost turns to the west? And then we shoot these pulses off. As soon as those pulses get shot off in that red rectangle, it starts going back towards the north and northeast here. So look at this back here. We see it's going north, and it almost has a very slight northwest component, north-northwest component. We shoot off our little football spikes, as I like to call them here, our frequencies that go up this way, rippling effect here, ring, 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 ring out here. And then again, this is your fixed environment. Again, we can see cloud kinking here, like this. And this lifts up in this way, and this is, there you go, guys. Then we're going to bring on your onshore flow right here. We're drawing in all this Atlantic moisture, and then we're just going to wreck these areas with heavy rain. Absolutely destroy them with heavy rain. Again, here's these stitches. Look at them out here, and you can see almost triangles, guys. These are like triangles pulsing. Absolutely nuts here. And here's the back edge of it. I trace it in my red outline again. This helps cap this. And note what's going on here. We see lines here. Here's the back edge of this. This travels up here in unison with this boundary. Okay, we can see a boundary here, a line here, a line here, a line here, and it just continues to lift up, guys. All of this, again, is can't stress this enough. This is dealing with weather that's not derived naturally. It's forced, it's manipulated, it's manufactured, whatever you want to call it. And all this does is it attacks everyone's livelihood. It damages our food supply. It damages people's property. And that's the point of this, okay? This is going to continue to be destructive to people, and it continues to desensitize people, and it normalizes having these massive hurricanes that undergo all of this rapid intensification. This is far from naturally occurring weather, guys, and they do it right in front of your face out in the open. No one is going to talk about this stuff because they're afraid to talk about it. They don't want to lose their job if they talk about it. As a meteorologist, there's just no explanation for people that refuse to see this as it is. If you don't see this as it is and you are a meteorologist, as I've always said, I really highly encourage you guys to look in depth at this stuff, because this occurs and this continues for as long as you allow it to. And I don't know about you, but I do not like the idea of having my house and my apartment and my livelihood, my family's getting destroyed by this weather, all at their own will, guys. This is extremely disturbing stuff, and it needs to be stopped. I have more details on how this stuff occurs. I didn't go really into the technical of what's behind what does this, but simply put, the NextRad network is in communication with HARP, and HARP is an ionospheric heater. The ionospheric heater can help create expanded columns of heated or excited air. And then once you do that, you can excite this via microwaving and pulsation, as well as putting stratospheric injections in the atmosphere that can be magnetized. And what do magnets do? They attract or they repel. And so you can magnetize our water vapor once you put these stratospheric aerosol injections in here. And that's how you can manipulate this in tandem with NextRad. And that's how we can get your artificial hurricanes, artificial low pressure systems, cold fronts, you name it, guys. They have a complete and control on our weather systems. I appreciate you sticking around and watching this. Very long evidence here. It took me about an hour to record this, guys. But again, I can't thank you enough for sticking around and watching this. Please share this with everyone. It's my goal to help you guys that aren't meteorologists to see this stuff. That's why this gets very technical, because in this day and age, just simply telling someone that the weather is manipulated and you need to look at it, that just doesn't cut it. People need to see it. I always believe on seeing is believing. Look up at the sky, guys. If you're walking out in the park, if you're taking a break from work, you need to go outside, start paying attention to the sky, and you'll notice that these things are very odd. And I'm going to close with this too, guys. The average average adult that is in the workforce, they spend 93% of their life indoors. So 7% of your life now is spent outside. How can you even know what it looks like outside when you're spending 93% of your life indoors? And then look back to the generations in the past. This is an age now of technology where everyone is now inside. There's less people that have jobs that are outdoors. And so naturally, you're going to start to lose a sense of reality of what's really going on outside. And so now I understand that you may not know better of what the weather is supposed to look like. So this is my goal, guys. I'm trying to show this to you. I'm trying to prove to you that these are not naturally occurring phenomenon. These are man-made. We're not dealing with Mother Nature anymore. This is extremely, extremely dangerous and disturbing, because it has a complete and total reckless care for what this is going to do downwind and what the implications are when you give and take in one spot of the atmosphere, guys. This throws off our Mother Earth's equilibrium and its natural state, and it can send things in a slew of chaos. Thank you so much for listening to this, guys. God bless. Stay safe out there. Thanks again.